Now let's see the concept of planarity in graph theory. So whenever you have a drawing like this, then it is called as a crossover. If you look at it, one edge is crossing over the other one. That is why it is called as a crossover. Now the planar representation of a graph is drawing the graph on a plane without any crossovers, which means if you are able to draw the graph in such a way that no two edges cross over each other, then that is called as a planar representation. A graph having planar representation is called planar graph. So if you can draw a graph in such a way that there are no crossovers, then that is called as planar graph, and if you can't draw it, then it is not planar, right? So if you take an example, if you see this is actually not a planar representation of the graph, right? And if you can get it into a planar form, then you can call it as a planar graph, right? So what is it? If you observe it, there is a crossover between these two edges. Now if I can draw this edge or this edge in such a way that it doesn't cross over the one other, then I can call it as a planar representation and the graph as a planar graph, right? So I could take this edge and I could pull it out and place it outside like this, right? If I write like this, then I got the planar graph. Okay, fine. And now once you have a planar representation of the graph, then something called as faces or regions will come into picture. So what is a place or region is? The planar representation of the planar graph divides the entire plane into faces. Now if you see this example, or even if you take a small example like this, if I have three vertices and a triangle like this, it is going to divide the entire region into two planes or two faces or two regions, right? So one region is inside and the other region is outside it. So one region and outside second region, right? Now if you have, see, this is also a representation which is having crossovers. So if I write the planar representation, I got it like this. Now after writing it like this, there is no closed surface, right? Which means there is no region which is actually bounded by the edges. Therefore you can say that there are no boundaries here, right? So in this case, if you observe it, all these three are actually bounding this particular region. That is why they are boundary edges as well. But here there is only one region, and which is completely open region. So this is also called as open region or open face. In this open region or open face, if you have only one in such a way, then no edge is actually bounding it. So there are no boundary edges. And now if you see this diagram, in this one you have phase 1, phase 2, phase 3 and phase 4, right? So phase 4 is the open phase and all the other are bounded phase, and every edge is actually bounding some phase. Got it? Okay, so that is all about the planar representation. We shall see some more properties on this. Now let's see these degrees. Degree of interior region is number of edges enclosing the region or face. Now if you see this face F1, it is enclosed by 3 edges, isn't it? That is why degree of F1 is 3. Now if you see the face F2, it is enclosed by 3 degrees. F2 is 3. F3 is also enclosed by 3 edges, 1, 2, 3, that is by 3. But if you see F4, that is called as exterior region. So these are all interior regions and this is exterior region because it is not bounded, it is open, isn't it? Now for the exterior region, the number of edges exposed to the face or region is called as its degree. Now how many edges are exposed? So 1, 2, 3, all these 3 are exposed to F4, as well as this edge is also exposed, but this edge is exposed 2 times, one on this side and other on this side. That is why the degree of this F4 is 5. Got it? Seeing this? Okay. Now for any planar graph with n vertices, sum of all degrees of the faces is equal to 2 into edges. So in this case, if you observe it, how many edges are there? 1, 2, 3, 4, 5, 6 and 7. 7 edges are there, right? Now 7 into 2 is 14. Now it is 9 plus 5, which is again 14. So if you observe it, sum of all degrees is equal to 2 into number of edges. So how is it possible is, if you observe this, every edge is actually contributing a number 1 to the degree, sum of all degrees, because if you observe this edge, if you take this edge, it is contributing a number 1 to this face as well as a number 1 to this face, right? Which means every edge is actually contributing a sum of 2 to the sum of all degrees. That is why every edge is contributing 2. Therefore, if all the edges is multiplied by 2, then you are going to get sum of all degrees. Got it? Okay. Now in a planar graph, k into f is equal to 2e if degree of every face is k. See, if every face degree is k, then what about the sum of all degrees? If we have f faces and if the degree of every face is k, then the sum of all degrees is going to be k into f, isn't it? Now if minimum degree is going to be k, so what does the minimum degree mean? If you look at all the faces and if you find out that the minimum degree of a face is k, then definitely k into f is less than or equal to 2e. So how to see it is, let us assume that we have n faces, f1, f2, f3, so on, fn, okay, and let us say their degrees are a, b, c, so on, let's say some k. Now if you replace all these degrees, so we know that if you add all these degrees, it is going to be 2 into e, right? Now if you replace all these degrees with the minimum of these numbers, right, let us say the minimum of all these numbers is a. If I replace all of them with a, then definitely a will be less than b, a will be less than c, a will be less than k. Therefore on the left hand side you are actually decreasing the number. That is why this has to be less than or equal to, if I add them all up, this has to be less than or equal to 2 into e. Are you getting this? Or other way of looking at it is, let us say you have some few numbers 2, 3, 4, 5. Let's say these are the numbers you have. Now I add them all up, 2 plus 3 plus 4 plus 5. Now what is the sum going to be? 14, right? Okay. Now if I replace every number with the least of these numbers, which means if I replace every number with 2, 2, 2, 2, definitely this sum is going to be less than or equal to 14, isn't it? When is it going to be equal to this right hand side? When all of them are going to have the same numbers, isn't it? So similarly, if these are all the degrees of the faces, if you replace every degree with the least degree and if you add them up, that is definitely less than or equal to the earlier sum, right? Earlier sum is actually 2 into e, that is what they are saying. Now what is the meaning of this? If degree of f is greater than or equal to k, means k is the least value of all the degrees, right? Now they are saying that if that is the case, then k into f should be less than or equal to 2 into e. And what about this one? If degree of f is less than or equal to k, means k is the maximum degree of all the faces, right? So now looking at this example, what they are trying to do is take the maximum number, which is 5, and you replace every number with 5. So definitely whatever sum you are going to get, it is going to be greater than the earlier number, isn't it? Therefore k into f should be greater than or equal to 2 into e, right? So we are going to use these inequations, and later we'll derive some more inequations which will be important for us to solve some questions. Okay, fine. Now in a planar graph with no loops, no parallel edges is called as simple planar graph. So that is just a definition of the simple planar graph. In a simple planar graph with at least two edges, the number of the degree of every face or region is at least going to be 3, right? So how is it possible is, if you have to form a face, you should at least have 3 edges. I am talking about the interior face. If you don't want an interior face, then this point will be applicable if you have at least 2 edges, which means let us say you have 2 edges like this, right? So then we are going to have only one face, which is nothing but the open face or exterior face, and for that one, if you try to find out the degree, then the degree is going to be 4, because it is exposed one time here, one time here, one time here, one time here. The degree is going to be 4. Therefore, if you have at least 2 edges, then in a simple planar graph, always the degree of every region is going to be 3. Why? See this. If you have a graph like this, the degree is going to be 4 for the open region R1, assuming that the entire region is open or exterior. Now, in this one, if you observe it in this graph, we have 3 edges and the degree of this region is 3 because it is bounded by 3, and the degree of the outside region is again 3. Got it? And similarly in this one, if you see it, let us say R2 is the degree inside it. Okay, and this is the face inside this square. Then what is the degree of this region is 4, right? And if you assume that this entire part is one graph, now you can see that the degree of the region R1 is 3 and the degree of region R2 is 4 because they are enclosed by 3 and 4 edges. And now the degree of the region R3 is a open region or exterior region, is number of edges exposed to it. So edges exposed to it are one time here, 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 one time here. Therefore it is going to be 7, right? Now as we know this, we have already seen this, right? So sigma sum of the degrees of all faces is equal to 2 into edges. Now I am saying that every face is going to have at least a degree of 3. Then 3 into f is less than or equal to 2 into e. So how is it possible is, see this, now I am saying here degree of region R1 in this case plus degree of region R2 plus degree of region R3, right? So is equal to 2 into number of edges. How many edges are there? 1, 2, 3, 4, 5, 6, 7, which means it is going to be 14, right? Now if you add them, 3 plus 4 plus 7 is 14, right? 3 plus 4 plus 7 is 14. Now they are trying to say that in a simple planar graph, which means this is a simple planar graph with at least 2 edges, the degree of every face or region is at least 3, which means every region is going to have at least a degree of 3. Therefore, if I replace the degree of every region by 3, instead of 4 if I replace by 3, instead of 4 if I replace by 3, then this entire sum is going to be 3 into number of regions in it, right? So 3 into number of regions or faces, 3 into faces. Now this sum is definitely less than or equal to 14. This sum is less than or equal to 14. That is what they are trying to say. If you replace the degrees of every region by the minimum degree possible, which is nothing but 3, then 3 into number of regions is less than or equal to 2 into edges. Why? If you observe it here, I am decreasing the left side, but the right side is going to be constant. That is why left side is less than or equal to right side. Got it? So when is it going to be equal? If all of them are exactly going to be 3, then it is going to be equal. Got it? Okay. Now we have Euler's formula. Euler's formula says that if G is a connected graph with n vertices, e edges and f faces, then n minus e plus f is equal to 2. So using this rule and all the inequalities that we know, we can now derive new inequalities using which some problems can be solved. Okay, we shall see that in the next video. Okay, fine. Now let's see this. If capital G is a simple planar connected graph with n vertices, e edges, f faces with at least 3 vertices. So they are saying that if this is the case, which means if a graph is simple, planar and it is connected, and if it is having at least 3 vertices, then they are saying that these two conditions are going to hold true. So how to prove it is, we are going to use Euler's equation. So what is the Euler's equation say? N minus e plus f is equal to 2. So this is what we already know. Now the second thing they are saying is, it is a planar graph and it is connected. So it is connected graph and it is having 3 vertices. Now whenever you have 3 vertices which are connected, they have to be connected this way, isn't it? At least whenever you have 3 vertices, and if you have to connect them all, then you should at least have 2 edges, isn't it? Now if you see this, there is only one region in this case, and the region's degree is going to be this 1 plus 1 plus 1 plus 1, which means 4, right? Or what is the other way we can form the regions? I can close it, and there are 2 regions, and the region of inside region is 3, degree of inside region is 3, and the degree of outside region is 3. Therefore, whatever way you try to form simple planar connected graph with 3 vertices, always the degree or the minimum degree of every face is going to be at least 3, or the degree of every face is going to be at least 3. Simple logic is, you will not be able to form any face without at least three edges. That is why degree of every face has to be at least 3. Now other way is, there is a chance that you might get a face of degree 2 only when you have one edge like this. But to rule out this possibility, they are saying that there are 3 vertices and all are connected, which means minimum your graph is going to look like this, and it is going to be bigger than this, right? So if it is going to be bigger than this, which means if it contains more edges and more vertices, then definitely whenever you try to enclose a region, that region will have at least 3 degree. So one thing you can use is minimum degree of a face. Minimum degree of any face is equal to 3. So it is going to be greater than or equal to 3. Now in that case, we already know that sum of all degrees, sigma f of I, sum of all degrees is equal to 2 into number of edges. We already know it, right? Now because each degree, minimum degree is going to be 3, each face minimum degree is going to be 3, I can write that 3 into number of faces is going to be less than or equal to 2 into E. How did I write this? Earlier I have shown you that if the minimum degree is K, I can write K into F is less than or equal to 2 into E, right? So from this inequation and from this equation, I can get these 2 inequations, right? So how to get it is, let's see the first inequation. In this one, we have derived this one from this one only. Okay, so if you see it, faces is not visible anywhere. Therefore, we are going to eliminate faces by using edges. So how can we do it? I can do it this way. Faces is less than or equal to 2 into E by 3. So what does it mean? This particular term is greater than faces. This particular term is greater than F, right? Now in this equation, in this entire equation, you have left hand side and right hand side, right? In the left hand side you have F. So in place of F, if I substitute something greater than F, then what happens? This entire left hand side is going to be greater than right hand side. Are you getting this? Earlier these two are equal, left hand side is equal to right hand side. Now in place of F, I am going to place something greater than F. Then what happens is N minus E plus 2E by 3 is greater than or equal to 2. So why did I get this? Because in place of F I am putting something greater than F. Therefore the entire left hand side is going to be greater than right hand side, greater than or equal to right hand side. So that is what I got. Okay, now what do I get? N plus, it is minus E by 3, right? Greater than or equal to 2. Now if you just simplify the terms, if you write it in terms of only E, then E will be less than or equal to, you are going to get 3n minus 6. Just rearrange the terms, you are going to get this one. Got it? Okay, now how to get the other inequation is, see this. Now I will use the same equation, which is n minus E plus F is equal to 2. I will use the same equation. Now if you observe it, here edges are not visible, right? So edges are not there. So what happened is, in place of edge, I have replaced using the term faces. So from this one, E is greater than or equal to 3F by 2, right? Now see this, this entire term 3F by 2 is less than E, right? Now if I replace in place of this E, if I replace 3F by 2, or if you are confused this way, you can write it N plus F is equal to 2 plus E. Now it will be clear for you. Now in place of E, you are going to replace with something which is less than E, right? Therefore, if you replace here some value which is less than E, then this entire right hand side is going to be less than left hand side, which means N plus F is going to be 2 plus 3F by 2. Now see this, in place of E we have replaced with something less. Therefore this right hand side is going to be greater than or equal to. Are you getting this? Okay. Now what is that? N. So we have to write in terms of F, right? Okay. N plus F. You can send F that side and get 2 this side. So N minus F is greater than or equal to F by 2. That implies f is less than or equal to 2n minus 4. So we got that. Alright. So these two inequations are drawn from this.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into university is better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.